Good day everyone, I'm Charles de Lanzaderas and I'm about to discuss turbine flow sensor. Turbine flow sensor. A turbine flow sensor is a type of flow meter that measures the flow rate of the fluid, such as liquid and gases, by utilizing the rotation of a turbine or rotor placed within the fluid stream. The speed of rotation of the turbine is directly proportional to the flow rate of the fluid. And this rotational motion is converted into an electrical signal allowing for accurate flow rate measurement and monitoring in a various industrial and commercial application. Working principle. Turbine rotor. The core working principle of a turbine rotor flow sensor lies in the rotation of turbine blades or a rotor when fluid flow through it. As the fluid moves As a fluid moves through the sensor, it impinges on the turbine blade, causes them to spin. This rotation is directly linked to the velocity or flow rate of the fluid. The faster the fluid flows, the quicker the blade rotates, and vice versa. Magnetic pickup coil. Inside the sensor, there is a magnetic pickup mechanism, which is often a coil or a Hall effect sensor, positioned near the rotation turbine blade. This pickup plays a critical role as the blades spin, they pass by the magnetic pickup, inducing changing in magnetic field or generated electrical pulses. Output signal. The interaction between the rotation blade and the magnetic pickup leads to the generation of an electric signal. The frequency or amplitude of this signal is directly proportional to the rotation speed of the blade, which in turn correspond to the fluid flow rate. Therefore, by the measuring the signal, the turbine flow sensor can accurately determine the rate at which the fluid is moving through the system. Calculation. The formula for calculating the flow rate using a turbine flow sensor is flow rate Q equals open parenthesis key times N close parenthesis divide T. Q is the flow rate in unit per unit of time, liter per second, gallons per second. K is the sensor's calibration factor, which relate the sensor output frequency, pulses per unit time, to flow rate T. N is the number of pulses or revolution detected by the sensor during a certain time period. T. T is the time period in which the pulses or revolution were counted. Time should be consistent with the sensor calibration factor. If the calibration factor is in pulses per minute, use minute for the time period. And that's all for my report. Thank you.